on this. Okay. So first Coulomb's law equation on the, so it is F is equal to K Q1 Q2 by R square, assuming these are placed in vacuum. Suppose in the charges on the vacuum place pandrena, so K value on the it is 1 by 4 pi epsilon. K value on the it is nothing but 1 by 4 pi epsilon, and K is equal to 9 into 10 power 9. So epsilon naught value on the 8.854 into 10 power minus 12. So K oda unit பார்க்கும்போது, so from this equation, so in the equation வந்து அது வந்து I'll write in the form of K. So it is Q1 the Q2 by R square. So K வந்து I'll write it as F into R square by Q1 Q2. F into R square by Q1 Q2. I'll write it here. Okay. So இது நான் வந்து force வந்து Newton, R square வந்து meter square, and Coulombs வந்து இங்க ரெண்டு charges இருக்கிறதுனால it is Coulomb square. So this is your unit for K. அதே epsilon naught permittivity ன்னு சொல்றோம். So epsilon naught ஓட unit வந்து K க்கு inverse. It is C square by Newton meter square. So these are your units and these are your relations. This is Coulomb's law equation. Other suppose in the Coulomb's law, when you see with respect to your vector format. Now on the vector format, this relation I see in vector format. Vector format I assume two masses. So mass M1 and mass M2 two masses, mass M1, mass M2. Two masses, these two are separated by distance of r. Okay. Now, இப்போ வந்து நான் ஒரு mass M1 மேல I'll apply some force. நல்லா பாத்துக்கோங்க, இது வந்து mass நான் positive நினைக்கிறேன், இது வந்து mass நான் negative நினைக்கிறேன். So no positive and no negative. So when you are placing it, so positive force என்ன ஆகும், it will try to attract. ரெண்டு attractive forces இருக்கும். ரெண்டு towards each other இருக்கும் from the Newton's third law. Okay, ரெண்டு towards each other இருக்கும். So if you see that force F1, நான் வந்து vector formatல பார்ப்பேன். Force F1, it was related with respect to 2. So 1, it was reacting with respect to 1 with respect to F12 and so on. This is relative motions. அதே மாதிரி இந்த side F2 force, it will try to relate with respect to F1. So F21 இங்கே F12. So நம்மளுக்கு already தெரியும். So F12 is equal to F21. Both are in opposite direction, but still both are same forces, equal and opposite forces. Okay. So now we'll see the relation. Suppose நான் என்ன பண்றேன்னா mass M1 வந்து நான் stationary சொல்றேன். Mass வந்து I'll keep this as stationary. Mass வந்து I'll keep this as stationary. Stationary நான் place பண்றேன். Stationary place பண்றேன். M2 வந்து நான் மூவ் பண்றேன். M2 மூவ் பண்ணும்போது நல்லா பாருங்க, it will try to move towards F12. So mass M12 towards இருக்கும். So I'll write the relation as F21 vector is equal to. So இங்க வந்து mass M1 is stationary இருக்கு, M2 move ஆயிட்டு இருக்கு towards M1. So it will try to move. So in the direction move ஆகும்போது இந்த distance என்ன ஆகும், it will try to decrease. Okay. So and இங்க வந்து distance எப்படி decrease ஆயிருக்குன்னா with respect to this one. So R it is 1 2, correct? So R12 it will try to decrease. So R12 base பண்ணிதான் it will try to decrease the distance. So இது base பண்ணிதான் distance decrease ஆகும். அதே மாதிரி F12 வந்து இந்த direction towards M2 move ஆகும்போது distance வந்து it will try to decrease with respect to 2 1. Okay. So F21 force பார்க்கலாம். So F21 force is equal to K. So stator the charges on the it is your scalar quantity. So Q1 Q2. Okay. So these charges are nothing but it is Q1 and Q2. Remember force on the directly proportional to your masses. Masses இருக்கிறதுனால தான் charges வந்து move ஆயிட்டு இருக்கு. Okay. So K is proportional to F is proportional to Q1 and Q2. So it is K Q1 Q2 by R square into R cap. This is your direction. R cap on சொல்றோம். R cap எப்படி வருதுன்னா F21 and R12 both are in the same direction. So remember F21 R12 ரெண்டு same directions இருக்கிறதுனால இதுக்கு வந்து reverse வரும். R12 cap. அதே நான் வந்து I'll write இந்த direction இல்லாம நான் vector formula எழுதும்போது so F21 vector is equal to it is K Q1 Q2 by R square into R vector, that is R12 by R magnitude. Okay, I'll write this relation as K Q1 Q2 by R cube into R vector 12. Remember this relation. Okay, so இங்க வந்து F21 வந்தா இங்க வந்து F12 வரும். இங்க வந்து R cap வந்து R square வரும். R vector வந்து R cube வரும். So this is your vector format. Now அதே வந்து when I'm writing this relation in terms of F12 பார்க்கும்போது the relation F12 is equal to, this is the relation. Okay, so you'll see the relation F12. So F12 vector is equal to it is K Q1 Q2 by R square into F12 வரும்போது so it is R21 வரும். So it is R21 direction. So it's equal to K Q1 Q2 by R square. அதே நான் வெக்டர்ல எழுதும்போது so it is magnitude R. So it is R21. So which is equal to K Q1 Q2 by R cube into R. It is 2 1 vector. So it is F12 vector. Remember this relation. So in the relation and in the relation. Okay, அதே மாதிரி. So if you see that F12 and F21 ரெண்டு சேமா இருக்கும், but the distance வந்து opposite direction இருக்கும். So that means R21 is equal to minus R1. ஏன்னா வந்து இது opposite direction இருக்கும். Okay, so these are your relations and vector formats. Okay, so இதை நோட் பண்ணிக்கோங்க. Just உங்களுக்கு தெரிஞ்ச ரிலேஷன்ஸ் தான் இது. ஓவர் வாய்ஸ் கிளியரா இருக்கா?
Yes, sir.
Okay, ma'am. பரவாயில்ல. Okay, நோட் பண்ணிட்டீங்களா?
Yes, sir.
நான் இதை erase பண்ணிட்டு. Okay, now we'll see about the electric field. So next one, electric field பார்க்கலாம். So electric field உங்களுக்கு வந்து என்னென்ன கான்செப்ட்ஸ் இம்பார்ட்டன்ட்னா, நம்ம when we are discussing about the properties of chargesல உங்களுக்கு வந்து quantization important. Q is equal to NE. Okay, இந்த ரிலேஷன் இம்பார்ட்டன்ட். இந்த ரிலேஷன் வந்து மறக்காதீங்க நீங்க. இந்த ரிலேஷன் வந்து ரிப்பீட் ஆயிட்டே இருக்கும், and as well as the Coulomb's law equations. So now next one we are going to discuss about your electric field. Electric field, for example, so what I'll do, I'll take a positive charge. ஒரு positive charge நான் எடுத்துக்கிறேன், there will be hang some field around it. So what are the field now discuss பண்றது? This is nothing but your electric field. Remember, in the electric field வந்து capital E, symbol வந்து capital E. So இதுக்கு வந்து different names இருக்கு. Electric field ன்னு சொல்லலாம், electric field intensity ன்னு சொல்லலாம், electric field strength ன்னு சொல்லலாம். நான் shortcuts தான் யூஸ் பண்ணிட்டு இருக்கேன். So electric field or electric field intensity or electric field strength. எல்லா இதுக்கு same meaning தான், which is the symbol is capital E. Now, in the positive charge, there will be having some field around it, and the field is the electric field. Electric field lines எப்படி இருக்குன்னா, always traveling, so it will be away from each other. So இது வந்து equally spread ஆகும் in all the directions like this. Okay, so எல்லா direction field lines வந்து travel ஆயிருக்கு. These are nothing but your electric field lines. These are nothing but your electric field lines. Now, when we are placing a negative charge, நான் வந்து இந்த ஃபீல்டுக்கு வெளியே ஒரு சார்ஜ் பிளேஸ் பண்றேன். இது வந்து நான் ஸ்மால் கியூன்னு சொல்றேன். இது சோர்ஸ். So remember, whatever the positive charge நான் எடுக்கும்போது அதுக்கு ஒரு ஃபீல்ட் இருக்குன்னு சொல்றேன். இது பாசிட்டிவ் சார்ஜுக்கு இது சோர்ஸ்ன்னு சொல்றேன். இது வந்து நான் டெஸ்ட் சார்ஜ் சொல்றேன். So இந்த பாசிட்டிவ் சார்ஜுக்கு away from it, I'm taking a negative charge. So place பண்ணும்போது என்ன ஆகும்னா, it won't attract at all. Attract ஆகாது because it is totally isolated. So இதுதான் நான் வந்து கன்சர்வேஷன் சொல்லிட்டு டிஸ்கஸ் பண்ணிருக்கேன். Suppose in the negative charge when we are placing inside the system, negative charge when we are placing inside the system, place பண்ணும்போது it will try to attract. அது attractive forces act ஆகும். So இதுக்கு மேல வந்து there will be handsome attractive forces. And remember one more thing, in the charge வந்து when we are placing inside the system only, there will be handsome forces. அப்போ relation வந்து because of the electric field, right, there will be having some forces acting on the test charge. So relation வந்து E is equal to F by Q. இதோட யூனிட் வந்து Newton per coulomb. E is equal to F by Q, which is nothing but Newton per coulomb. So it is your unit. Okay, now so then one more thing. So இது வந்து positive charge and இது வந்து negative charge. These two are separated by a small distance r. Again ஒரு force act ஆயிட்டு இருக்கு, that is your attractive force. So F is equal to K capital Q small q by the distance is r square. இப்போ நான் என்ன பண்றேன்னா, இந்த force நான் இதுல substitute பண்றேன். When you are doing it, E is equal to, it is K capital Q small q by r square by Q. Q will get cancelled. It is nothing but K capital Q by r square. This is your electric field relation. இது ஒரு field relation with respect to your distance. இது with respect to distance, இது with respect to your force. ரெண்டு same units தான். இப்போ நீங்க வந்து இது திரும்பி find out பண்ணாலும் you'll get the same units, which is Newton per coulomb. Okay, remember this unit is Newton per coulomb. This is your electric field. So electric field relation வந்து ரொம்ப important. Now, so when we are discussing about the dipole, so just take these relations. E is equal to F by Q ஒரு equation இருக்கு, and E is equal to K Q by R square ஒரு relation. So whatever thing we are discussing about, it is your electric field. It's your electric field. Right, ma'am. Note பண்ணிட்டீங்களா? எல்லாமே நோட் பண்ண தேவையில்லை. நான் எக்ஸ்பிளைன் பண்றேன். உங்களுக்கு வந்து டவுட்டா இருந்தா ப்ளீஸ் ஆஸ்க் மீ. as usual records அப்படிதான் இருக்கும். இந்த ஈக்குவேஷன்ஸ் வந்து நீங்க நோட் பண்ணிக்கோங்க. ஓகே, மெசேஜ் பண்ணிருக்கேன். எஸ் சார். ஓகே, நான் எரேஸ் பண்ணிடுறேன். So next one we'll see about the dipole. நான் வந்து ரொம்ப இம்பார்ட்டன்ட் ரிப்பீட்டட் क्वेश्चंस அந்த கான்செப்ட்ஸ் தான் நான் எக்ஸ்பிளைன் பண்ணிட்டு இருக்கேன். ஓகே, சோ சின்ன தேவை. So dipole. So anyone, what is dipole? So இதுல வந்து கான்செப்ட்ஸ் எப்படி இருக்குன்னா, dipole will discuss about the dipole moment. We'll discuss about the dipole moment, which is P vector Okay, because there is a direction, and we are discussing about the applications of dipole moment. Actually, applications வந்து ஒன்னு axial point இருக்கு, ஒன்னு equatorial point இருக்கு. Axial point இருக்கு, equatorial point இருக்கு. இது பேஸ் பண்ணி தான் we are going to find out the electric field. Okay, right, one by one we'll see. So dipole is nothing but two charges, two equal and opposite charges separated by a small distance. It is minus q and it is plus q. These two are separated by a small distance, that is nothing but your dipole moment. Dipole. Okay, two charges, equal and opposite charges separated by a small distance is dipole. Dipole moment now, it was equally divided from its center. So it is length and it is length. So rendu vandu equal divide agum from the center towards each other. Now, so dipole moment is always traveling from negative towards the positive. There are direction always traveling from negative towards the positive. I'll take it as p vector. And either a relation, so here both the charges are there. So here both are identical charges. So either one charge into the separation between the two charges. It is q into 2n. So dipole moment relation வந்து q into 2l. இதோட unit வந்து q is coulomb and l is your meter. இது meter square இருக்காது. 2l na meter square கிடையாது. It is meter only. So it is coulomb meter. Centimeter கிடையாது, coulomb meter. So நீங்க வந்து specify பண்ணிக்கோங்க. It is coulomb meter. So it is your dipole moment. Now when we are discussing about the dipole moment, நான் ரெண்டு applications சொல்லிருக்கேன். ரெண்டு applications ல first one we'll see it is your axial point. First one we'll see your axial point. Okay, just remember this dipole moment. It's a very important relation. Okay, and remember, நம்ம வந்து இப்போ electrostatics lo first chapter நம்ம discuss பண்ணிட்டு இருக்கோம். In the first topics lo whatever we are discussing, like நம்ம வந்து dipole moment, axial, equatorial, Gauss law, இந்த concepts திரும்பி magnetism lo வரும். Moving charges lo magnetism lo வரும். We'll discuss with respect to the bar magnet. இங்க வந்து dipole charges பார்க்கிறோம், அங்க வந்து bar magnet base பண்ணி பார்க்கிறோம். So in the formulas எல்லாம் நீங்க வந்து first chapter lo நல்லா clear-ஆ இருங்க. இதே concepts, இதே formulas திரும்பி we'll discussing magnetism. Okay, so உங்களுக்கு வந்து அப்போ ஈஸி ஆயிடும், சாப்டர் வந்து கொஞ்சம் ஈஸியா நம்ம கிளியர் பண்ணிடலாம். So electrostatics தரவா இருங்க. Right, so we'll discuss about the axial point. So it is one of your application for dipole. Now I'll take a dipole. So dipole, it is minus charge and it is plus charge. So both are separation by a small distance of 2l. From the center it is l and from the center it is l. So center point I'll take it as O. Center point I'll take it as O. Now in the dipole, it is one of the application. I'll write the name. So it is your axial due to dipole. Okay. So in the dipole, so when you're placing a point P, okay, on the same axis, in the dipole on the same axis at a particular distance, I'm taking a point P. I'm taking a point P. So when you are placing a point P, in the point P, I'm going to find the electric field due to this dipole. So electric field due to this dipole. In the dipole, I'm going to find the electric field here. So for that, in the negative charge A point and positive charge I'll take it as B point. Now in the center point, to this point P, I'll take the distance. So I'll take the distance as x. The distance I'll take it as x. அதே மாதிரி B point P point I'll take it as x minus l. நான் வந்து x minus l வந்து நான் சப்ட்ராக்ட் பண்ணா I'll get this distance. அதே மாதிரி A point P point, P point, I'll take the distance as x plus l. Okay, so these are your relations. Now we are going to find the electric field. Remember, electric field now on the find out at the P point and சொல்லும்போது assume this dipole is your source. நான் வந்து உங்க assumption base பண்ணி தான் நான் சொல்லிட்டு இருக்கேன், and to remember these things easier நம்ம memorize பண்ண. So what I'll do, so I'll take a positive charge here. இது வந்து test charge. So because of the source வந்து move ஆகாது towards the test charge. So only test charge மட்டும் தான் move ஆகும் towards the source. Remember. இப்போ நான் என்ன பண்றேன்னா இது A point, first I will see with respect to the A point. Okay, A point வந்து negative charge, இது வந்து positive charge. What will happen? It will try to attract. So in the test charge it will try to attract towards the A point. So I take this one as A point. ஏன்னா வந்து இந்த attractive force இருக்கு with respect to A. And B point பார்க்கும்போது இது positive and இங்கே இருக்க relation வந்து positive. So B point positive and P point positive. So for that இங்கே வந்து repulsive force act ஆயிட்டு இருக்கு and it will try to move in this direction. So it is your EB. So now we are going to find the electric field. So electric field actually on the additive property தான் E is equal to EA plus EB மட்டும் தான் நம்ம பண்ணணும். ஏன்னா when we are discussing about the electric field, இது வந்து vector quantity. Remember, electric field வந்து vector quantity because we are specifying with respect to directions, and directions நம்ம வந்து specify பண்ணும்போது charges வந்து நான் negative எடுக்க மாட்டேன். Remember, நான் direction specify பண்ணிட்டேன்னா charge negative எடுக்க மாட்டேன். Now, So first of all, we will see directions. இங்க directions இருக்கிறதுனால நான் charges negative எடுக்க மாட்டேன்னு சொல்லிருக்கேன். First directions பார்க்கும்போது the dipole moment is always traveling from negative towards the positive. Remember, இது negative towards the positive இருக்கு and EB both are in the same direction. So electric field at the P point, I'll take it as E axial is equal to EB is positive because dipole moment and EB ரெண்டு same direction. Okay, I'll specify in vector formats. Minus EA. So dipole moment and EA both are in opposite directions, so it is minus EA vector. So this is your axial point at P point. Okay, axial at P point. Now, first EA pakla. So EA is equal to, so it is K, right? So I told you the relation electric field E is equal to KQ by R square and so relation. நம்ம இப்போதான் பார்த்தோம். So from this relation, இங்க வந்து நான் source base பண்ணி தான் நான் discuss பண்ணிட்டு இருக்கேன். So electric field it is E. இங்க வந்து நான் நெகட்டிவ் சார்ஜ் நான் எடுக்க மாட்டேன். நான் ஆல்ரெடி சொல்லிட்டேன். இங்க ஆல்ரெடி நான் வந்து டைரக்ஷன் பேஸ் பண்ணி நெகட்டிவ் எடுத்ததுனால it is KQ by R square. A point and the P point, the distance was x plus L. So it is x plus L whole square. It is x plus L whole square. Now, EB is equal to, it is KQ by, the distance is x minus L whole square. So it is x minus L whole square. So these are your electric fields E and EB. Now, adula na substitute pandren. First equation. So it is EB is KQ by x minus L whole square minus KQ by x plus L whole square. Okay. So நான் இதுக்கு உங்களுக்கு ரிலேஷன்ஸ் கொடுத்துட்டு இருக்கேன்னா ஸோ உங்களுக்கு வந்து கான்செப்ட்ஸ்ல ப்ராப்ளம்ஸ்ல இந்த மாதிரி வந்து கொஸ்டின்ஸ் வர சான்சஸ் இருக்கு. அதனால நான் எக்ஸ்பிளைன் பண்றேன். டெரிவேஷன்ஸ் எல்லாம் பண்ண மாட்டேன். ஐம் ஜஸ்ட் எக்ஸ்பிளைனிங் திஸ். ஸோ இங்க வந்து KQ நான் காமன் எடுத்துட்டு when you do the cross multiplication I'll get the final equation as like this. KQ into 4XL KQ into 4XL by x square minus L square whole square. This is your final equation. In the மாதிரி now final equation lo na enna pandrena I'm just linking the dipole moment here. So now on the dipole moment link pandren. So in the 4 on the I'll write it as 2 into 2. I'll write it as 2 into 2. So it is 2k into 2ql into x. So in the x separate பண்ணிட்டு k2 na separate பண்றேன் q2l. So q into 2l is nothing but your dipole moment. So I'll write this as x square minus L square whole square. So final equation on the 2kpx by x square minus L square whole square. This is your electric field for axial point. Remember this relation, the axial point. Okay. So இங்கே ஒரு ஸ்பெஷல் கேஸ் இருக்கு. இந்த ஃபார்முலா மட்டும் எனக்கு இம்பார்ட்டன்ட் தான். Remember இது வந்து actual relation. இப்போ if the dipole is shorter, suppose if the dipole is shorter, that means so x is much greater than L. If the dipole is shorter and the distance from the center point x is much greater than L, அப்போ E axial relation என்ன ஆகும்னா E axial is equal to, it is நான் வந்து L neglect பண்ணிட்டேன். So the relation will be 2kpx by x power 4. L நான் neglect பண்ற denominator, so it will be x cube. So it is 2kp by x cube. Remember this relation when the dipole is shorter. So the relation important. Okay, so நான் வந்து நல்லா பார்த்துக்கோங்க. ப்ராப்ளம்ஸ்ல வரும்போது we have to compare the relation. X greater இருக்கா lesser இருக்கா. So after comparison only நான் வந்து இந்த ஃபார்முலா எடுக்கணுமா first equation இல்ல வந்து second equation எடுக்கணுமா சொல்லிட்டு நான் கன்சிடர். X is much greater than L இருக்கும்போது தான் we have to consider. So ஒரு சின்ன எக்ஸாம்பிள் பார்க்கலாம். So if x வந்து ஒரு 50 centimeters இருக்கு. நல்லா பார்த்துக்கோங்க. X வந்து 50 centimeters, L வந்து 0.1 centimeters இருக்கு. L வந்து 0.1 centimeters. இதோட கன்வர்ஷன்ஸ் நீங்க பார்க்கும்போது it was so small. Even though centimetersல இருந்தாலும் இது ரொம்ப small values இருக்கிறதுனால so we can take the second equation. Or else இப்போ suppose x is equal to 50 centimeters இருக்கு. நல்லா பாருங்க x 50 centimeters, 2L வந்து it is your 20 centimeters. 2L வந்து 20 centimeters. இந்த மாதிரி இருக்கும்போது so it is so comparison வந்து பெரிய டிஃபரன்ஸ் இல்ல. So have to take the first equation. Depends upon your relations. Now the second equation or first equation I'll consider. Okay, so இது நோட் பண்ணிக்கோங்க. If you have any difficulty please let me know. நோட் பண்ணிட்டீங்களா? only அந்த formulas மட்டும் தான் important and இந்த picture வந்து நோட் பண்ணிக்கோங்க அவ்வளவுதான். வேற எதுவும் வேண்டாம். Right?
Yes sir.
Right now, super. Okay.
Yes sir.
So now I just we'll see the next one. Now, second application for the dipole. Let's see the second application for the dipole. It is your equatorial. It is your equatorial. So when we are discussing about the equatorial, same dipole I எடுத்துக்கிறேன். So when we are discussing about the dipole, so it is your negative charges and it is your positive charges. It is A point, it is B point, and from the center, the distance will be splitted. So it is L and L. I'll take this 2L, the total distance. Now, so in the center point, I'll take it as O. So for this dipole, now on the midpoint, I'll take a perpendicular point. So center point, I'll take a perpendicular point. Dipole, I'll take a perpendicular point. So I'll take this point as P. I'll take this point as P. So perpendicular point which is away from the dipole. So I'm going to find the electric field at this point. So now the inge electric field I find out pandren. To find the electric field, first on the assumption based panira, so then only it will be easy. This is positive charge. Remember, it is your positive charge. Okay, so positive charge inge mela electric field form ஆயிட்டிருக்குனா, that means A நந்து ஒரு field form ஆகும், அதே மாதிரி B நந்து ஒரு field form ஆகும். So this is A point to P point. Okay, அதே மாதிரி P point to B point. P point to B point. So it is like a equilateral triangle. Now, this perpendicular point, I'll take this P to O, I'll take it as X. P to O, I'll take it as X. Now, if you see that negative charge, A on the negative charge A on the negative charge and P on the positive charge. Now, already selected dipole, assume it is your positive charge, it is your dipole, it is as source. I'll take this dipole as source and in this positive charge as test charge. Positive charge, test charge. If it will try to attract. If the negative, it will try to attract. It will try to attract in this direction. So I'll take this as EA. Now, adhe madri, inge positive charge inge positive charge. What will happen? It will try to ripple. Okay. Sorry, one second. So what will happen? It will try to ripple. So ripple on the same direction of the ripple agum. So this is your EB. Okay, this is EA and EB. So now, இப்போ distance பார்க்கலாம். So A point to P point. If you see that இதே நான் வந்து right angle triangle. Right angle triangle தான். So இங்க வந்து ரெண்டு portions right angle triangles இருக்கு. ரெண்டுமே same angle theta ல தான் it was making the point P. Okay. Now, so இது ஒரு right angle triangle நான் draw பண்ணிருக்கேன். So if you see that it is your perpendicular point, I'll take this one as X, I'll take this one as L. இங்க தான் angle theta பண்ணிட்டு. So if you see that இது opposite side, the adjacent side, and it is nothing but your hypotenuse. So hypotenuse is nothing but your opposite side plus adjacent side square root. So it is square root of x square plus L square. So hypotenuse it is square root of x square plus L square. Adhe madri inge square root of x square plus L square. The distance both are same. Remember, distance rendu same ah da irukku. Now, so we'll see the same point P. I'll draw here. So inge vandu na draw pandren. So this is your EA. This is EA. And idhe madri EB in the direction. EB in the direction. Now, we already resultant already resultant is nothing but your electric field. So this is your resultant electric field. I'll take this one as E. இப்போ EA பார்க்கலாம். So இந்த லைன் பார்க்கலாம். EA and இந்த angle theta. So whatever this electric field resultant, இது வந்து base dipole ஓட parallel இருக்கிறதுனால so same angle theta இங்க பண்ணிருக்கு. A கிட்ட என்ன angle பண்ணிட்டு இருக்கோ அதே angle இங்க பண்ணுது. அதே மாதிரி B கிட்ட என்ன angle பண்ணிட்டு இருக்கோ அதே angle இங்க பண்ணுது. Both are parallel to each other. Now, so when any object making an angle theta with respect to the axis, in the axis on the axis, it is parallel to the base. So I'll take this one as EA cos theta. Adhe madri with respect to EB, it is EB cos theta. Okay, but idhukku perpendicular irukku. So idhukku perpendicular it is nothing but it is EA sin theta, and idhukku perpendicular it is nothing but your EB sin theta. Okay, now if you see that sin theta's angles rendu same. Okay, and distance ella same. So EA, EB rendu same ah da irukum. So EA is equal to KQ by distance it is square root of x square plus L square whole square. Square root will get cancelled. Correct? So which is equal to, the relation will be, it is KQ by, so it is KQ by x square plus L square. This is EA. அதே மாதிரி EB. ரெண்டு same ah da irukum. ரெண்டு சேமா தான் இருக்கும். Now, so from this relation, நீங்க வந்து EB sin theta, EA sin theta ரெண்டு opposite இருக்கு. So I'll take it as EA sin theta is equal to EB sin theta, or EA sin theta minus EB sin theta is equal to 0. So ரெண்டுமே cancel ஆயிடும். So this is your sin theta relations. Okay. Now, இப்போ electric field பார்க்கலாம். So இந்த electric field வந்து it is a combination of both EA and EB. So electric field E is equal to EA cos theta plus EB cos theta. If you see that EA cos theta, EB cos theta rendu same direction irukadunala na add panniten. So it is nothing but equatorial. I'll take it as EQ. So E suffix Q equatorial. Now it is EA cos theta, EA cos theta. So if you know cos theta from this relation, adjacent by hypotenuse, it is L by root of x square plus L square is your cos theta. Okay, ரெண்டு side இப்போ நான் பார்க்கும்போது first one right angle triangle இருக்கு, second one right angle triangle, both are having same sides, same distance நால cos theta ரெண்டுத்துக்கு same, angle theta ரெண்டுத்துக்கு same. So and EAEB ரெண்டு same. So what I'll do, நான் வந்து ரெண்டு add பண்ணிட்டேன். So I'm going to find the relation. Okay, so it is, so 2 times nala EA is nothing but it is k q by x square plus L square into cos theta, and cos theta is nothing but L by square root of x square plus L square. So now direct relation kuduthurren, it is 2k q L by is x square plus L square whole power 3 by 2. Okay, inga na paakumbodhu, so x square plus L square in the term, so 2ql, it's nothing but your dipole moment, so it is kp by, remember it is kp by x square plus L square whole power 3 by 2. So this is your E equatorial relation. It is your E equatorial actual relation. This is your actual relation. Okay, now when you're discussing about this actual relation, idhula vandu or special case irukka sollirken. So in the special case enna, if the dipole is shorter, dipole vandu shorter ah irukku, that means x was much greater than L. If x was much greater than L, x much greater than L and solumbodhu, what will happen, we can neglect L in the denominator. So for relation enna agum, E equatorial is equal to kp by x cube. ஏன்னா இங்க வந்து square, இங்க 1 by 2 will get cancelled. So this is your equatorial. EQ is equal to kp by x cube. So remember this relation. This is the first equation, this is the second equation. Okay, so special case, இது முன்னாடி சொன்ன மாதிரி, so it depends upon the special case, இந்த formula வந்து நான் relate பண்ணேன். Okay, okay. ஏதாவது difficulty இருந்தா please let me know. இந்த formulas மட்டும் நோட் பண்ணிக்கோங்க, அந்த picture வந்து memorize பண்ணிக்கோங்க. Pictures base பண்ணி தான் உங்களுக்கு questions இருக்கும். Or?
Yes, sir.
Okay, fine. So others please note panikkonga. So I'm just erasing it. Okay, so here next one we'll see about your torque. Idhe na dipole base pani we are going to see torque. So torque relation romba important. Torque relation romba important. We'll discuss about the torque. Eppadi in torque. So to find the torque, what I'll do, I'm taking some field lines. So now some field lines note panikren. The field lines are traveling from positive towards the negative. So no field lines of the travel from positive towards the negative. In this field lines, I place pandrena, I'm placing a dipole. So in this field lines, I'm placing a dipole. Or a dipole on the place pandren. So I assume this is your dipole. So dipole on salamodu, they'll be having some positive charge and they'll be having some negative charge. Okay. So these two are separated by a distance of 2l. The dipole on these two are separation by a distance of 2l. So it is your distance. It is your 2l. Now, so in the dipole, I'm placing inside the electric field, making an angle theta. But angle theta la in the dipole on the place pannittu. When I'm placing it, nalla parunga idu positive charge irukku and inge vandu positive charge irukku. So they'll be having some repulsive forces. Or a field kulla na vandu or positive charge na place pandrena, because of this electric field, they'll be having some forces acting on it. Adha nama vandu electric field E is equal to F by Q and so to discuss pannom. So inge vandu or force actor irukku. Remember in the forces ella linear force la da irukum. So here the force, so it is F is equal to plus QE. And adhe madri, because of this negative, it will try to repel. But in a positive, it will try to attract. So again, they'll be having some forces on this negative charge. Again, F is equal to minus QE. So rendu side forces act agum, both are parallel to each other. Now it is theta. So angle theta la na place pandren. So torque formula enna, torque is equal to force into perpendicular distance. So force into perpendicular distance. This is your equation. Now, ipo the angle theta, it was making angle theta with respect to electric field. Remember, it was making angle theta with respect to electric field. So angle theta na, it is your hypotenuse. So it is, can I write it as, it is 2l cos theta. When any object making angle theta with respect to axis, it is 2l cos theta. Appo idu perpendicular point irukum. Idala perpendicular point enna, this is your perpendicular point from the base. So idala perpendicular point distance vandu, I'll take it as it is 2l sin theta. Remember, so இது வந்து angle theta ல தான் நான் வந்து ஒரு dipole place பண்ணிருக்கேன். With respect to axis னு சொல்லும்போது it is 2l cos theta ஆகும். Perpendicular னு சொல்லும்போது it is 2l sin theta. Okay, now we'll see the relations. when torque is equal to force into perpendicular distance. Perpendicular distance another, it is 2L sin theta. It is 2L sin theta. Now if you see that, so force and சொல்லும்போது either one force. ஏன்னா வந்து ரெண்டு forces same தான் இருக்கும். Both are in opposite direction but still same forces தான் இருக்கும். So I'll take either one force. F is equal to QE into 2L sin theta. If you see that 2LQ is nothing but your dipole moment. So P is your dipole moment into E sin theta is your torque. So this is your final relation. T is equal to PE sin theta. T is equal to PE sin theta. Now, these are special cases here. So they'll be having some special cases. If theta is equal to 0 degrees, that means parallel dipole on the parallel with respect to your electric field. If theta is equal to 0 degrees, torque on the 0 again on the sin 0 0. Second case, if theta is equal to 90 degrees. If theta is equal to 90 degrees, அப்போ torque என்ன ஆகும்னா it is maximum torque ஆகும். Remember, torque will be maximum when theta is equal to 90 degrees. அப்போ relation வந்து it is PE. Okay. And third case, if theta is equal to 180 degrees, இது வந்து opposite direction இருக்கு. So then torque is also 0. So sin 180 is 0. Sin 0 is equal to 0. Sin 90 is equal to 1. Suppose அது வேணும்னா நீங்க note பண்ணிக்கோங்க. Sin 180 is equal to 0. Okay, so these are your relations and this torque relation is important and special questions in the memorize பண்ணிக்கோங்க. T max is equal to P. Okay, so this is a அங்க questionல என்னன்னா theta is equal to 90 degrees ன்னு கேட்க மாட்டாங்க. They will ask you what is the maximum torque. So அப்போ torque வந்து T max is equal to P. Remember, this is your torque. Okay, note பண்ணிக்கோங்க. நோட் பண்ணிட்டீங்களா? ஓகேமா. So I'm just erasing it. Others கொஞ்சம் நோட் பண்ணிக்கோங்க. நான் erase பண்ணிட்டேன். Okay, right. So you'll see the யாருமாவது கொஞ்சம் மியூட் பண்ணுங்கம்மா. Okay, thank you. Okay, so we'll see your continuous charge distribution. So இங்கிருந்து நம்ம டைபோல் பார்த்திருக்கோம், அதோட axial point, equatorial point, torque relations, இந்த relations எல்லாம் important. இதை விட ரொம்ப important வந்து உங்க Gauss law. So Gauss law போறதுக்கு முன்னாடி we'll see your continuous charge distributions. Continuous charge distributions. So இதுல வந்து 3 types இருக்கு continuous charge distributions. First type வந்து linear. Just relations மட்டும் நான் கொடுத்துறேன். Second வந்து surface. First one the linear, second one the surface, third one on the volume. So ஒரு linearல ஒரு conductor, for example, ஒரு conductorல there will be having some charges present. So charges present, இது வந்து infinity lengthல இருக்கும். Okay, இதுல வந்து நான் என்ன பண்றேன்னா I'm taking a small portion. When I discussing of the small portion, it is nothing but your dl. So total charges q ன்னு சொல்லும்போது when we are discussing the small change, it is your dq. So linear is nothing but the symbol is lambda. So lambda is your linear charge density. We call it as linear charge density. Linear charge density in the symbols எல்லாம் memorize பண்ணிக்கோங்க, இந்த names எல்லாம் important. Linear charge density lambda is equal to dq by dl, or we can specify it as q by l. Okay, இதோட யூனிட் வந்து q by l ன்னு சொல்லும்போது the coulomb is the charge is coulomb and length is meter. அதே மாதிரி surface the symbol is sigma. Sigma is equal to q by a. Sigma is equal to q by a, coulomb per meter square is your unit. And volume on the, it is 3 dimension, it is rho. I'll take it as rho. Rho is equal to q by v. It is equal to coulomb per meter square. Sorry, meter cube. Coulomb per meter cube. It is your relation. So linear, surface and volume. இதுல நம்ம Gauss law discuss பண்றது linear, surface நம்ம discuss பண்றோம். The relations வந்து ரொம்ப important. Okay, right. இது note பண்ணிக்கோங்க. Then we'll see the Gauss law. Just a statement பண்றேன் நான் சொல்றேன். So Gauss law என்னன்னா, so assume before going to the Gauss law. So Gauss law முன்னாடி we'll try to see or we'll try to understand electric flux. Electric flux. So flux symbol வந்து phi. Flux symbol வந்து phi. Remember flux is but flow. நீங்க வந்து suppose flux difficult இருக்கு understand பண்ணதுன்னா remember flux as flow. So phi is equal to formula என்னன்னா EA cos theta. Flux phi is nothing but your EA cos theta. இது எப்படி வந்திருக்கு நம்ம பார்ப்போம். So note பண்ணிட்டீங்களா இது linear?
Yes, sir.
Okay, so we'll discuss about the flux. To understand the flux, நான் வந்து ஒரு சின்ன example நான் பார்க்கிறேன். So what I'll do, நான் lines தான் draw பண்ணணும். Okay, I'll take a cube. Okay, so I'm taking a cube. So in the cube, I'm placing this cube on the axis. Okay, on the axis of a fixed thing. ஒரே நிமிஷமா நான் கொஞ்சம் டிஃபிகல்ட்டா இருக்கு. Okay. பென்சில் சாக் பீஸ் இருந்தா பிரச்சனை இல்லை. ஆர்டிஸ்ட் மாதிரி ட்ரா பண்ணிருக்கேன். Okay, so assume it's your cube. So I'm placing this cube on your x-axis. Or axis மேல நான் வந்து இந்த cube நான் வந்து place பண்ணிட்டேன். So x-axis மேல I'm placing this cube. Okay, like this. Okay, so when you're placing this cube, இது வந்து இது x-axis, it was flowing like this, and இது வந்து y-axis. Remember, in the x-axis மேல நான் வந்து cube place பண்ணிட்டு இருக்கேன். So when you're placing this cube, நான் வந்து ஒரு electric field lines, few electric field lines pass பண்ணிட்டு இருக்கேன் from the origin. So from the origin, I'm placing some electric field lines. So these are electric field lines E. So the electric field lines it will try to pass through the cube. So pass it will try to come out of it. One side enter, one side will leave. One side it was entering, one side it was leaving. So these are nothing but your electric fields. Okay. Now in this cube, only two sides are getting affected. Two side mattum the effect ஆயிட்டு. So first side it is from the left side. So only in the portion which is at the left side mattum the effect ஆயிருக்கு. So top bottom at the edges எதுமே effect ஆகல. So front back. So எதுமே effect ஆகல. Only the left side and as well as the right side portions are affecting. Only left side and the right side portions are affecting. Now நல்லா பாத்துக்கோங்க. So in the cube whatever the areas we are going to consider, இது வந்து area projection. Okay, area projection தான் நம்மளுக்கு important. இங்க நான் right side பார்க்குறேன் first. So either area projection, it will be towards your electric field. Like for example, now on the right side, so area projection, the projected area on the it was towards your right side. Adhe madri left side area projection also it will project it towards your left side. Like a book. Okay, book la on the field lines pass பண்ணிட்டு இருக்கேன். If you see the book, இது வந்து projection வந்து outward projection it will be left side. In the side of the outward projection will be right side. Okay, so if you see that ரெண்டு வந்து opposite direction இருக்கு. Both are in opposite direction. So theta is equal to 180 degrees. I'll take this. Theta is equal to 180 degrees. And on the rend same direction. So theta is equal to 0 degrees. Okay. So theta 180 and theta 0. So in the Mari type of questions on the important. And remember one more thing. Area projection on the surface perpendicular. Remember area projection on the surface perpendicular. So now we'll see one more thing. Okay, the first case is the second one, and next one is your third. Now I am a particular angle I am placing this surface or area or angle projection now or surface or angle projection நான் place பண்ணிருக்கேன். இதுக்கு perpendicular தான் area projection இருக்கு. Okay, area projected outwards. ஒரு surface நான் எடுத்துக்கிறேன். So இதோட area projection வந்து outward direction இருக்கு. இப்போ நான் என்ன பண்றேன்னா I'll take some field lines, electric field lines நான் place பண்றேன். So when I'm allowing some electric field lines passing through it, so this is your electric field lines, it will take an angle theta. So it was making an angle theta. You see that it was making an angle theta. So angle theta it was fine. Now, so angle theta place பண்ணிட்டு area இருக்கு. If you see that, so it is making angle theta with respect to the axis. So I can take this. It is a cos theta. A cos theta. So here the flux is nothing but the field lines passing through any closed surface. The field lines passing through any closed surface. So flux phi is equal to field lines passing through. Field lines is nothing but electric field lines are passing through any closed surface. Phi is equal to EA. But because of this angle theta, so phi is equal to EA cos theta. Remember, na idhukku vandu ivula explain panna thevilla, but you will get the questions like this only. Or object kuduthiruvanga illa or surface kuduthiruvanga, depends upon the surface area projection. You have to consider what is the angle theta. Adi base panni formulas ella irukum. Now, so if you see that, or special cases part. So here there are three cases are there. If theta is equal to 0 degrees. Remember, if theta is equal to 0 degrees, cos 0. Remember cos 0. So what is cos 0? Anyone? Okay. So if theta is equal to 0, yes, ma. 1, sir. Okay. So if theta is equal to 0 degrees, cos 0 is equal to 1. So then flux phi is maximum. Okay, remember that flux phi is maximum. Second case, if theta is equal to 180 degrees, If theta is equal to 180 degrees, cos 180 is equal to minus 1. Cos 180 is equal to minus 1. Then flux phi is minimum flux. Phi is your minimum flux, which is equal to minus EA. Remember that. அதே மாதிரி third case, if theta is equal to 90 degrees, perpendicular point இருக்கும். Perpendicular point இருக்கும்போது field lines எதுவுமே affect ஆகாது. So then other case, so the relation flux phi is equal to 0. So if theta is equal to 90 degrees, flux phi is equal to 0. So you can take it down. So cos 0 is equal to 1, cos 90 is equal to 0, and cos 180 is equal to minus 1. Remember these three cases. This is your flux in the formula important. Phi is equal to A cos 0. Let's take it down. Or
Yes, sir.
okay, good. Right. So I'm erasing this one. So next one, so important one. This is your Gauss law. So இதோட வந்து ஸ்டேட்மெண்ட் ப்ரூஃப் பார்க்கலாம். தென் அப்ளிகேஷன்ஸ் வந்து நான் எக்ஸ்பிளைன் பண்றேன். நான் ஃபுல்லா டிரைவ் பண்ண மாட்டேன். I'll give the final relation applications. So Gauss law statement வந்து the field lines passing through a closed surface. When the field lines passing through a closed surface, that is flux phi is equal to E into ds is equal to Q by epsilon naught. That is 1 by epsilon naught times the charge. This is your statement. So field lines passing through a closed surface, phi is equal to closed integral. Closed integrations எப்போ யூஸ் பண்றோம்னா, so if you want to add anything, we are going to integrate it. So நம்ம small changes எல்லாம் add பண்ணும்போது integrate யூஸ் பண்றோம். When you want to split it, we are using the differentiation part. So flux phi is equal to closed integral E into ds is equal to Q by epsilon. Now, இதோட proof பார்ப்போம். So for that, what I'll do, I'll take a sphere, a small sphere நான் எடுத்துக்கிறேன். So when you're taking a sphere, இதுல வந்து I'll take a positive charge. In the sphere, I'll take a positive charge. So positive charge, and either a radius I'll take this R. So in the sphere, I'll take the radius R. So in Apakamodu, the field lines are always traveling in all the directions. So field lines in the all directional travel. So from this sphere. Okay, so whatever the sphere we are taking, this is your conductor. Okay, now, so here for this sphere, so I'm taking a small change. So total surface I'll take it as S. Total surface I'll take it as S. Okay, so this is a small change. Remember, I'm just discussing about the small change. When you're taking a small change, this is nothing but your ds. So I already told you when we're discussing about the ds, இது வந்து surface projected outward direction இருக்கும். So இது inside இருக்காது, it will be surface projection outward direction. For this surface, the projection is outward like this. So this is your ds. Now on எந்த point வேணா எடுத்துக்கலாம், எங்க வேணாலும் எடுத்துக்கலாம். When you're taking a small surface, the field lines will be passing through it. அதோட projection area வந்து அதுக்கு perpendicular. This is your perpendicular point. Now, so in the surface area, it was getting affected. So this surface area was getting affected when the field lines are passing through it. So field lines on the pass side. So it will be passing like this. So it will be passing like this. So electric field and ds surface change both are having an angle theta. So if you see that both are in same direction, so theta is equal to 0 degrees. When theta is equal to 0 degrees, nalla paranga in the area on the effect aayirukku. What are the area it was getting affected? This area we call it as Gaussian surface. So we call it as Gaussian surface. Okay, now we'll see the relations. So flux phi is equal to, it is your closed surface. It is not closed surface. Open surface, sometimes it will be open. Okay, so flux phi is equal to closed integral electric field E into ds is equal to, electric field on the E, so I'll separate it, integral ds is equal to E into integral ds. Integration, differentiation both are in opposite terms, so it will get cancelled. So electric field E into, it is nothing but your area. This is now the first equation. Okay, now, so the same thing, we are going to prove Q by epsilon from this. So now the Q by epsilon now prove it. To find that electric field part, so electric field is nothing but this positive positive charge, I'll take as capital. Electric field is nothing but E is equal to KQ by R square. Remember, electric field E is equal to KQ by R square, and K is nothing but it is 1 by 4 pi epsilon naught Q by R square. This is your relation. Now either substitute பண்றேன். So when you are substituting here in this relation, so electric field E is equal to, it is 1 by 4 pi epsilon naught, it is Q by R square. And what is the area of a sphere? The area of a sphere is nothing but your 4 pi R square. So 4.45 will get cancelled, r square will get cancelled, which is equal to q by epsilon r is nothing but your flux. So this is your relation for Gauss law. So remember, flux phi is equal to closed integral electric field lines passing through it a surface is equal to q by epsilon r. So remember this relation. So in the flux law, in the Gauss law, there are three applications out there. First one linear. Second one surface. First one linear, second one surface. Third one your spherical. Spherical surface outside, inside, and on the surface. And there are three conditions. So these three relations are important. So not particular like Gauss law. Yes, sir. Okay, fine. So I'm just erasing it. So now erase it. Okay. So now we'll see your linear. So to find the linear, இப்போ நான் என்ன பண்றேன்னா I am just taking a infinity length conductor. ஒரு infinity length conductor நான் வந்து எடுத்துக்கிறேன். ஸோ ஒரு infinity length conductor. அந்த infinity length conductorல நல்லா பார்த்துக்கோங்க, ஒரு wire சொல்லும்போது infinity lengthல வந்து what I'll do. So இதுல வந்து first case, remember it is your linear charge density. It was relating with respect to your Gauss law. Okay. இதுல வந்து infinity length conductorல நான் என்ன பண்றேன்னா நான் வந்து கட் ஷார்ட் பண்ணிடுறேன். ஸோ அதை கட் பண்ணிடுறேன். டூ சைட்ஸ் வந்து நான் கட் பண்ணிடுறேன். கட் பண்ணும்போது இதோட லென்த் வந்து நான் ஸ்மால் லென்த் எடுத்துக்கிறேன். இன்ஃபினிட் லென்த் கண்டக்டர்ல வந்து அதை கட் பண்ணிட்டு ஐ வில் டேக் a small portion of length here. So இது வந்து it was projected like this. One side வந்து it will be projected like this and other side it will be projected like this. So conductor ன்னு சொல்லும்போது remember there will be having some charges passing through it. So this is your conductor. On the top it is your insulated layer. Okay, so there will be having some charges present in it. So I assume there are some charges. நான் எல்லாம் டிஸ்கஸ் பண்றது this is your static electricity. இங்க வந்து charges flow ஆயிட்டு இருக்கு, current பத்தி நான் எதுவுமே பேசல இது வரைக்கும். Okay, so remember this. So these are nothing but your positive charges. Okay, now for this the length of the conductor வந்து நான் L. So what I'll do, நான் இதுல வந்து ஒரு 3 different sections வந்து நான் எடுத்துக்கிறேன். ஏன்னா வந்து இங்க left side இருக்கு, right side இருக்கு, on the surface இருக்கு. So இதோட directions எப்படி இருக்குன்னு பார்க்கலாம். So here I'm taking this portion as A point. And here this side, right side on the I'll take it as B point. On the surface, curved surface mela, I'll take it as C point. So moon point now they take it. In the moon point on the first of all we'll see. For this A point, the area projection is towards your left side. So this is your small change now I'll take it as DS. And adhe madri it will be projected towards your right side. It is your DS. And adhe madri on the top it is nothing but your DS. This is your surface change, perpendicular surface. Now electric field part. So always remember, நான் ஆல்ரெடி சொல்லியிருக்கேன், கண்டக்டர்ல the field lines will be perpendicular. So நான் வந்து இந்த பாயிண்ட் A எடுத்துக்கிறேன்னா it will be perpendicular downward direction. This is your electric field lines. கண்டக்டருக்கு perpendicular. Suppose இந்த பாயிண்ட் A நான் டாப்ல எடுத்தேன்னா it was passing in upward direction. That's it. B பாயிண்ட் மேல எடுத்தேன்னா it will moving the upward direction. Okay, எங்க வேணாலும் எடுத்துக்கலாம். So depends upon the points. So this is your electric field. So இங்க theta பார்க்கும்போது both are perpendicular. So here it is 90 degrees. So theta is equal to 90 degrees. Here also perpendicular. Here theta is equal to 90 degrees. Okay, but inge paakabodu, so it is your conductor perpendicular to the electric field line, so it is moving upward direction. This is your electric field. So in paakabodu here theta is equal to 0 degrees. One A point 90 degrees, B point 90 degrees, and C point is your 90 degrees. Now relations paakabodu, so flux phi. So flux phi is equal to flux on the induce பண்றது, flux phi is equal to, here three combinations are there. All three combinations are integrating with each other. Okay, so closed integral electric field E into ds. I'll take the cos theta because here it was making an angle theta. So now integrating all the three conditions. So integral B plus integral C. So in the combinations formula எல்லாம் include பண்ணி தான் நான் வந்து add பண்ணணும். So now first case, if theta is equal to 0 degrees, sorry, theta is equal to 90 degrees, A point, cos 90 is 0, so it is 0. So 0 plus, again B point, again 0, it is 0 plus. Here C point, here theta is equal to 0 degrees. And now closed integral, it is electric field E into ds. This is your relation. So that means flux phi is equal to E into E constant into ds is equal to E into area. So it is your first point. Okay. Now, so remember when we are discussing about the area which it was covering. Okay. So first of all, we'll see. So the total curved surface. So curved surface on the total length it is nothing but 2 pi r. Okay, so இதோட area சொல்லும்போது into L because we are considering with respect to the length. Okay, so இதோட curved surface, okay, இதோட surface area It is area of a curved surface. The formula is 2 pi r into L. So the relation we'll see. So the relation I'm going to substitute here. Okay. So I'm going to substitute the relation in your flux first equation. Okay. So flux phi is equal to, I'll take the relation like this. Flux phi is equal to E into 2 pi r L. So E into 2 pi r L. So, and one more thing, when we are discussing about the surface, it is your linear charge density. So it is lambda. Lambda is equal to Q by L. What I'll do, so instead of charge, that is flux phi is equal to Q by epsilon naught. So instead of charge, now the linear charge density la substitute. So Q is equal to lambda into L. Q is equal to lambda into L. I'll substitute here. So which is equal to lambda L by epsilon naught. So I'm going to equate first and second equations. When I'm equating first and second relations, so the relation will be, so it is electric field E into 2 pi r L is equal to, that is equating 1 and 2. Okay, 2 pi r L is equal to lambda L by epsilon naught. Lambda will get cancelled. So electric field E is equal to lambda by 2 pi r epsilon naught. This is your final equation. Okay, so the equation note பண்ணிக்கோங்க and in the picture வந்து memorize பண்ணிக்கோங்க. Okay, so எல்லா point நான் integrate பண்ணிட்டு இருக்கேன். So these are your things. Okay, note பண்ணிக்கோங்க. So this is your first application for your Gauss law, linear charge density. Electric field के linear charge density தான் we are equating. Over ma? Okay, right. So I'm just erasing it. Okay, so second case. So நமக்கு வந்து செகண்ட் இருக்கு. செகண்ட் வந்து சர்ஃபேஸ். ரிமெம்பர் சர்ஃபேஸ்ல வந்து ரெண்டு டிஃபரெண்ட் பாயிண்ட்ஸ் இருக்கு. சர்ஃபேஸ்ல வந்து ரெண்டு பாயிண்ட்ஸ் இருக்கு. ஒன் வந்து சிங்கிள் பிளேட். So for that what I'll do, நான் வந்து ஒரு சிங்கிள் பிளேட் எடுத்துக்கிறேன். சிங்கிள் சார்ஜ். இது வந்து ஹெட்டிங் வந்து it is nothing but your surface charge distribution. Okay, infinity length charge plane sheet. Okay, now so assume I'm taking a surface here. When I'm taking a surface, in the surface area on the I'll take it as S. So in the surface area, so single sheet மாதிரி தான் இருக்கு, plane sheet மாதிரி இருக்கு. It is infinity length. இதுல so they'll be having some charges. Now on the positive charge எடுத்துக்கிறேன். So it was equally divided in all the directions. In the charges வந்து it was equally divided in all the directions. எல்லா direction charges வந்து split ஆயிருக்கு, distribute ஆயிருக்கு. இதுல நான் என்ன பண்றேன்னா, I am taking a small portion. ஒரு சின்ன போர்ஷன் நான் வந்து எடுத்துக்கிறேன். ஸோ இந்த சின்ன போர்ஷன் நான் எடுத்துட்டு லைக் பேப்பர்னு சொல்லியிருக்கேன். சின்ன போர்ஷன் எடுத்துட்டு நான் வந்து ரெண்டு சைடு I'll try to extend it. ரெண்டு போர்ஷன்ஸ் I'll try to extend like this. இது ஒன் சைடு. அதே மாதிரி லெஃப்ட் சைடு வந்து அதே போர்ஷன் I'll try to extend. Left side I'll try to extend like this. So extend பண்ணதுக்கு அப்புறமா இதோட ஏரியா ப்ரொஜெக்ஷன்ஸ் வந்து நம்மளுக்கு இம்பார்ட்டன்ட். ஸோ அதே மாதிரி இதுக்கு முன்னாடி நம்ம எப்படி பாயிண்ட்ஸ் எடுத்திருக்கோமோ அதே மாதிரி I'll going to take the points. So here I'll take this A point, so small change, and here I'll take this B point, small change on the surface. It is your cursor is I'll take the C point. Now when you're taking about the points, இதுல வந்து surface projections பார்க்கலாம். So area projection. So it is your ds, it is your right side, it is your ds, it is your left side. On the top of the curved surface, it is upward direction. Surface ke perpendicular. Now electric field lines, it is your conductor. Field lines வந்து perpendicular இருக்கும் எப்பவுமே. So field lines perpendicular னு சொல்லும்போது the field lines will be traveling perpendicular to it. So it is your electric field which is perpendicular. Okay, and for the C point also it is perpendicular. This is your electric field. And A point also it is electric field which is perpendicular to the surface. Here if you see that angle theta part, here theta is equal to 0 degrees. Here theta is equal to again 0 degrees at the B point, but here theta is equal to 90 degrees at the C point. Now flux phi part, flux phi is equal to closed integral E into ds. So closed integral A point plus closed integral at the B surface plus integral at the C point. If you see that A one it is 0 degrees, so I'll take it as E into ds. Plus B one the other 0 degrees, so I'll take it as E into ds. But C one it is perpendicular theta is equal to 90 degrees, it will be 0. பார்க்கும்போது ரெண்டு எலக்ட்ரிக் ஃபீல்ட் அண்ட் சர்ஃபேஸ் ரெண்டு சேமா இருக்கும். So it is 2 times closed integral E into ds is equal to flux phi. So I'll write it as 2 into E into area. It is the first equation. Now அதே மாதிரி சர்ஃபேஸ் னு சொல்லும்போது sigma is equal to Q by A. So Q is equal to sigma A. Okay, I'm going to substitute this relation in flux phi is equal to Q by epsilon naught. So it is equal to sigma A by epsilon naught. This is your second equation. So equating these two, when I am equating these two, I'm going to write the relation final. So it is 2EA is equal to sigma A by epsilon. Area constant irukadnala AA will get cancelled. So electric field E is equal to sigma by 2 epsilon. This is your relation. Remember, in the for single surface charge density or single surface charge distribution. Okay, remember this relation. This is single plate. அதே மாதிரி multiple plate அதே மாதிரி capacitor இன்னொரு relation இருக்கு. We'll discuss. Okay, the relation ரொம்ப important. E is equal to sigma by epsilon. Just take it on. Yes, ma'am. Only on the picture and the relation மட்டும் note பண்ணிக்கோங்க. So எல்லாமே தேவையில்லை. Okay, or?
Yes, sir.
So I'm just erasing it. Now we'll see the idhula surface layer there is one more thing. Heading on the so opposite surface charges, opposite plates, opposite charged plates, opposite charged plates. So we are going to discuss about the opposite charged plates. So with respect to electric field. Okay. Now we'll see the relations. Now when we are discussing about these things, so first of all, I'll take a positive plate, positive charge for a plate now at the crane. So I assume this is your plate. So opposite charges are at the crane. Remember that. So it is your positive. Same thing, I'll take one more plate. Parallel to, closer to each other. Both are closer to each other. So both plates are closer to each other. So these are your plates. So here it is your positive charges. Right. So assuming it is your positive charges. Okay, so எல்லாமே வந்து positive charges இருக்கு on the plate A. I'll take this one as A point nala. So for the surface density, I'll take it as sigma. And in the B plate nala, I'll take this as sigma B. So it is negative charge. So రెండు positive, one is opposite charges. Both are opposite charges. One is positive plate and one is negative plate. These two are separated by a distance of D. These two are separated by a distance of D. Now, first the electric field is separate travel agum. For this positive plate, so the field lines will be perpendicular and it will be away from it and solirkum. So in the field lines only it will try to travel away from it. It is EA. And in the side they'll be having some EA. So both are traveling. And in the surface what will happen? It will try to pass through it. It is EA. So it is electric field lines EA. Both are traveling. Okay, in both directions it will try to travel. Now EB problem. EB only because of the negative field lines only it will try to pass towards it. It is EB field lines. And it is EB field lines and it is EB field lines. Now, so for these cases, in the other case, so what I'll do, I'll take three different conditions. Okay, three different regions. Pakena on the rend side, outside and inside on the one. I'll take first point, second one, and third. First region, second region, and third region. I'll take three different regions. Now, electric field pakla. Electric field as E is equal to EA and EB both are in opposite direction. I'll take EA minus EB for the first case. And second case I'll take it as E is equal to both are in the same direction. So it is EA plus EB. And in the case both are in opposite direction. So E is equal to EA minus EB. Now, we already single plate EA is equal to, I'll take as sigma A by 2 epsilon. It is nothing but for single plate electric field. So it is EB is equal to sigma B by 2 epsilon. Now I'm going to substitute the relation here. So it is sigma A minus sigma B by 2 epsilon. The denominator same. I'll take like this. For this case, my voice clear. Sorry, network issues. So that's disturbed. Okay, I'll just displaying again. Okay. Voice check pannikonga. Network issues disconnect aayiruchu. I'll just explain again those things. So, ipo clear the voice?
Yes, sir.
Okay, ma'am. Right. Okay. So, same thing now on the board display panirken. Now, so idu munadi nama discuss panna madiri da na thirumbi draw panna maten. Adu time waste da. So, idu three regions irukku. First region, second region, third region solirken. First region la vandu rendu opposite direction irukum. Second region la rendu same direction irukum. Third region la vandu rendu opposite direction. So for this case, E and aguna, it is EA minus EB and solirken. That is your sigma A minus sigma B by 2 epsilon naught. இங்க வந்து ரெண்டு சேம் டைரக்ஷனல்ல it is E is equal to A plus EB ன்னு சொல்றோம். That is equal to it is sigma A plus sigma B by 2 epsilon naught. And the third case, E is equal to A minus EB, which is equal to sigma A minus sigma B by 2 epsilon. Remember, first three cases. So, இங்க பார்க்கும்போது first and third cases வந்து outside இருக்கு, second case வந்து it was inside. Now, assuming if sigma A, both surfaces are same, ரெண்டு surface densities ரெண்டு same இருந்தா, outside the electric field will be 0. So, and inside it is sigma by epsilon naught. Remember, electric field will be there between the two plates, both are same. Okay, so if both plates are having same energy densities, the electric field E is equal to sigma by epsilon naught between the two parallel plates. Remember, this is positive plate, this is negative plate. This is A plate, this is B plate. Sigma A and sigma B relations. Sorry, ma, திரும்பி வந்து issues இருக்கு. இருக்கீங்களா? வாய்ஸ் கிளியரா இருக்கு இப்போ? Hello? Sorry, sir.
Yes, sir.
Continuously disconnect ஆயிட்டே இருக்கு எனக்கு. Right. So the relation மட்டும் note பண்ணிக்கோங்க. I'll write the relations. So electric field between the plates is E is equal to sigma by epsilon naught. So one positive plate, one a negative plate. Outside the fields, outside the plates, the electric field E is equal to 0. Just remember this relation. Enough. Okay. So between the plates, two oppositely charged plates, அதோட surface densities ரெண்டு சேமா இருந்தாதான் இந்த relation வந்து equate ஆகும். Okay, இது two parallel plates. For single plate வந்து E is equal to sigma by 2 epsilon naught. Okay, இது முன்னாடி நம்ம டிஸ்கஸ் பண்ணிருக்கோம். ரெண்டு ஃபார்முலாஸ் இம்பார்ட்டன்ட். Okay, remember this too. Okay. Now, so when we are discussing about these relations, so in the last one வந்து spherical இருக்கு. So spherical வந்து ரொம்ப இம்பார்ட்டன்ட். I hope network issues எதுவும் இருக்கு. Okay, இந்த ஃபார்முலாஸ் நோட் பண்ணிட்டீங்க. Okay. So நான் வந்து third case நம்ம பார்க்கலாம். Third case வந்து spherical. Third case வந்து spherical surface. Spherical surfacesல வந்து இதுல வந்து three different relations இருக்கு. One வந்து, so assume I'm just taking the sphere. So this is your first condition, first case. So I'm taking a sphere. I'm taking a spherical shell. Okay, so spherical shell இது வந்து conductor. Remember, it is your conductor. I'm placing some charges on the conductor. So conductor னு சொல்லும்போது charges வந்து it will be placed on the surface of the conductor only. Charges will be placed on the surface of the conductor. Okay, so like this. So இதோட radius வந்து from the center point as R. So radius வந்து I'll take it as from the center point I'll take it as capital R. So assume I'll take it as capital R. Radius வந்து I'll take it as capital R. Now in the surface conductor there will be having some field lines. Field lines என்னாகும், it will try to travel away from it like this. So எல்லா direction perpendicular point the field lines will be there. So what I'll do on the surface of the conductor I'll take a point P. ஒரு point P நான் எடுத்துக்கிறேன். So இந்த point P நான் வந்து spherical நான் draw பண்ணும்போது இந்த point P if I draw in a spherical format, so it will try to create a field around it like this. So it will be like a spherical. So இந்த மாதிரி spherical இருக்கும். So இப்போ நான் வந்து இந்த point P நான் எடுத்துக்கிறேன்னா spherical formatல whatever the area it was covering. Okay, ஏன்னா வந்து electric field lines pass ஆயிட்டு இருக்கு. இந்த area full electric field lines pass ஆயிட்டு இருக்கு. Whatever the area we are discussing, this area we call it as Gaussian surface. So whatever the area it was getting affected, in the area on the we call it as Gaussian surface. Okay. So in the first case on the first case is nothing but the electric field lines passing towards a point P, which is outside the spherical shell. It is outside the spherical shell. So outside the spherical shell. Now we'll see the relations. So here the flux phi is equal to closed integral electric field E into ds and so on. So remember, electric field lines are passing from the surface to the point P. In the மாதிரி வந்து electric field lines pass ஆயிட்டு. Now, what I'll do, I'll take the conductor ஓட distance நான் பார்க்கிறேன். From the center, the distance towards the point P, I'll take it as smaller. So the distance towards the point P, I'll take it as smaller. இதர distances வந்து capital R is greater than smaller. Sorry, smaller is greater than capital R. இது first case. So now electric field lines will be passing, okay, away from the surface. So it will be passing away from the surface. It is passing your P point. Okay, this surface we call it as Gaussian surface. Now, relations part. So electric field E into closed integral ds is nothing but E into the surface area is A. So for relation of the surface area of the sphere is 4 pi small r square. Remember, it is your first equation. So field lines on the away from it also, it is 4 pi r square. Now, next one, it is q by epsilon. Q by epsilon, because of the surface, I'll take it as Q is equal to sigma A by epsilon. Okay, so area, because area which was covering for the surface, okay, I'll take this area as capital R. So it is sigma into 4 pi capital R square by epsilon naught. I'll take this one as second equation. So equating these two, electric field E into 4 pi small r square is equal to, it is a sigma 4 pi capital R square by epsilon naught. So 4 pi will get cancelled. So electric field E is equal to sigma by epsilon naught into capital R square by small r square. So this is your relation. Remember this relation. Okay. So point P away from it, capital R is greater than smaller and சொல்லும்போது, okay, sorry, smaller is greater than capital R and சொல்லும்போது, this is your relation. E. Okay. Just take this relation. Point P away from it. Okay. In the relation important, this is the first case where smaller is greater than capital R. Not particular. Yes, sir. Okay, fine. So we'll see the second case. I'm just erasing it. Now the delete pointer. Okay. So you'll see the second case. Second case is smaller is equal to capital R. That means whatever the point P we are taking, it was on the surface. On the surface. On the point P on the I'm taking on the surface. Now we'll take the relations. Or surface எடுத்துக்கிறேன். Okay. So இதோட radius from the center. The radius from the center. So I'll take it as smaller and capital R. రెండు same தான். Okay. So charges are on the surface of the conductor. Charges are on the surface of the conductor fully. Okay. So charges full ஆயிருக்கு. Now நான் வந்து ஒரு பாயிண்ட் பி எடுத்துக்கிறேன். எங்க வேணாலும் எடுத்துக்கலாம். அந்த சர்ஃபேஸ் சொல்லும்போது எங்க வேணாலும் எடுத்துக்கலாம். இதோட ரேடியஸ் ரெண்டு சேம் ஆயிருக்கு. ஃபர்ஸ்ட் plus பார்க்கலாம். phi is equal to closed integral E into ds. So it is nothing but E into area. It is nothing but 4 pi r square into electric field E. First equation. இங்க r is equal to r ன்னு சொன்னதுனால so இப்போ வந்து என்ன ஆகும் q by epsilon naught is nothing but it is sigma into 4 pi capital R square by epsilon naught. இது ரெண்டு equations. Okay. So I am equating first and second. When you are equating first and second, 4 pi r square into E is equal to sigma into 4 pi r square by epsilon naught. So 4 pi r square will get cancelled. So electric field E is equal to sigma by epsilon naught when you are placing a point P on the surface of the conductor. Okay, so this is your relation. Okay, either on the surface. This is the second point. So next one, third one, Pakla. So remember, it is for smaller is equal to capital R case. Okay, it is on the surface. Remember, it is on the surface relation. Now we'll take the point P which is inside. Third case, we'll take a point P which is inside. So there will be having some charges. But charges will be on the spherical shell. So it will be spread in all the directions. Either the radius from the center, I'll take the capital R as usual. Okay. Now I'm taking a point P inside. For point P now on the place when you're placing this point P, this is a field create. So this is your field. I'll draw this field. Okay. So in spherical. So this is your field. Now center point I'll take this distance as smaller. I'll take this distance as smaller. So this point P which is lies inside. So point P lies inside a spherical shell. Inside spherical shell. Okay. So that means smaller it is less than capital R. Now third case remember smaller is less than capital R. Smaller is less than capital R. Okay. Now we'll see the relations. So here flux phi is equal to closed integral E into ds. So which is equal to E into area, which is equal to E into area for this radius. It is 4 pi. It is capital R square. So it is a first equation. But for the second case another q by epsilon naught is nothing but your flux. Nalla parunga, charges are on the spherical shell. On the spherical shell. But inside there are no charges. Inside there are no charges. Conductor there are no charges present inside the conductor. Only charges present on the surface of the conductor. So for this case, q is equal to 0. Remember inside the charges q is equal to 0. When q is equal to 0, so here flux is equal to 0. So flux present inside the point P. If it is equal to 0, which is equal to electric field. So again, E is equal to 0. Electric field E is equal to 0 inside the spherical shell when charges is equal to 0. This is third case and it is second case. Okay, remember these relations. The relations important. Note பண்ணிக்கோங்க. Okay, super ma. Okay, I'm erasing this one. Okay, so problems on the what I'll do tomorrow, we'll discuss about the problems. இன்னைக்கு வந்து இந்த கான்செப்ட்ஸ் கிளியரா டிஸ்கஸ் பண்ணிட்டு உங்களுக்கு ப்ராப்ளம்ஸ்க்கு நான் என்ன பண்றேன்னா I'll send you some screenshots with answers நான் சென்ட் பண்றேன். ரொம்ப இம்பார்ட்டன்ட் இது. So just go through that questions பாருங்க. ஏன்னா வந்து இனிமே வந்து நீங்க ரஷ் பண்ணணும். சண்டே வந்து electrostatics, what are the topics we are going to discuss? Okay, so till tomorrow's class. Okay, so நாளைக்கு கிளாஸ் வரைக்கும் நம்ம என்னென்ன எலக்ட்ரோஸ்டாட்டிக்ஸ் பத்தி டிஸ்கஸ் பண்றோமோ, so these things are there for your Sunday's test. Okay, உங்களுக்கு ஆன்லைனா ஆஃப்லைனா சொல்லிட்டு நான் உங்களுக்கு இன்ஃபார்ம் பண்ணிடுறேன். ஓகே, ரிமெம்பர் நான் என்ன சொல்லியிருக்கேன், கிராவிடேஷன், லாஸ் ஆஃப் மோஷன் அண்ட் யுவர் எலக்ட்ரோஸ்டாட்டிக்ஸ், இந்த 3 கான்செப்ட்ஸ் ரொம்ப இம்பார்ட்டன்ட் கான்செப்ட்ஸ் இது. ஐ கிவ் த கொஸ்டின்ஸ் டு யூ. ஸோ நீங்க வந்து ப்ராக்டிஸ் பண்ணுங்க, ட்ரை பண்ணுங்க. நான் அதுல நெகட்டிவ் மார்க்கிங் கிடையாது, ஜஸ்ட் ஃபார் யுவர் ப்ராக்டிஸ் அலோன் ஐ அம் சென்டிங் யூ திஸ் கொஸ்டின்ஸ் ஃபர்ஸ்ட் ஆஃப் ஆல். அதுக்கப்புறம் உங்களுக்கு வந்து டெய்லி வந்து ஒரு ஒர்க் ஷீட் இருக்கு, டெய்லி இனிமே ப்ராக்டிஸ் பண்றது ஸ்டார்ட் பண்ணுங்க. உங்களுக்கு வந்து இனிமே உங்களுக்கு நீட் எக்ஸாம் 26 இருக்கா இல்லையா, நீங்க ப்ராக்டிஸ் பண்றது மிஸ் பண்ணாங்க. ஓகே, ரைட். So here we are going to discuss about the electric potential. Next one is your electric potential. Electric potential. So இன்னும் கொஞ்சம் ப்ராக்டிஸ் ஆகணும் வந்து தானே. ஓகே, so electric potential. So first of all we'll discuss about the electric potential difference. Potential difference na எப்படி இருக்கும், அதோட ரிலேஷன் என்ன, அதுக்கப்புறம் நம்ம potential பார்க்கலாம், potential energy பார்க்கலாம். All these things we'll discuss now. So for this electric potential, so what I'll do, I'll take a positive charge. ஒரு சார்ஜ் நான் எடுத்துக்கிறேன் which is capital. So in the charge there will be having some field around it. In the charge there will be having some field around it. இதோட radius I'll take it as smaller. Okay, so a positive charge, I am taking a capital Q as your positive charge and அதோட radius வந்து R. So in the point I'll take this B point. On the surface I'll take this as B point. On this B point at a particular distance or else infinity location. So I'll take infinity location. Infinity location or point A irukku. I'll take this one as positive charge. Okay, small q. Okay, so infinity location lo edha or point irukku. Okay, so this is your positive charge. Now inge on the B point irukku. So this is your distance on the R irukku. This is your source. Okay, surface. Now in the positive charge I have to do some work. So inge on the infinity location in the positive charge I have to shift to the point B. Okay, A point I have to shift to the point B. B point ki shift pannanom. Shift pannanona, that means I have to do some work. Oru work pannanom, relation between these two I'll write as work done AB. Okay, A point and the B point ki I have to do some work. So when I'm doing some work, that means it is nothing but I have to apply some force acting on it. Or force apply pannadana, there will be having some change in its displacement. I'll take this as displacement X. In the there are different sections are there. Okay, on the different sections are clear. When you are considering this different section, I'll take the section as dx, small changes. So if you remember that work done on the, we have, I told you there are two different formulas are there. W is equal to Fs one here, W is equal to dW is equal to F into ds and so. So this is nothing but your variable work function. So integrating on both sides, integral F into the dx. So it is initial point to final point. So this is your work function. Now that means when you're placing this charge from A point to, when you're shifting from A point to B point, there'll be having some potential difference between these 2 points. A point to B point, there'll be having some potential difference. That potential difference is relating between A to B. So it is A point to B point. So VAB is equal to, so it is final minus initial. So it is a VB minus VA. Remember, it is VB minus VA is equal to potential difference between these 2 points is nothing but work done on your test charge. So this is your relation, potential difference. Potential difference between these 2 points, the VB minus VA. Okay, so it is final point to the initial point. Remember, VB minus VA is equal to W by Q. And when we are discussing about the W by Q, இதோட யூனிட் வந்து ஜூல் பர் கூலும். இதோட யூனிட் வந்து ஜூல் பர் கூலும் ஆர் வோல்ட். It is nothing but your voltage. It is nothing but your volt. Potential difference between these 2 points is volt. Okay, now இது potential difference. This is your potential difference, PD, or voltage and சொல்றோம். Okay, now we'll see the potential at one particular point. Okay, or we can say potential at the point B. Potential at point B. At point B. So when you're discussing about the potential at point B, so what I'll do, so potential at infinity location. Infinity location la enna potential enakku theriyadhu. So what I'll do, at infinity location, I'll take the potential as 0. So VB minus 0 is equal to work done by charge. So V is equal to W by Q. It is nothing but electric potential. It is single point potential. It is on the difference potential. So VB minus VA and V is equal to W by Q. Adora unit is same, that joule per coulomb or volt. Okay, so this is your relation. Now when you're discussing about the work function, இங்க வந்து work function இருக்கு and இங்க வந்து potential இருக்கு. So இங்க வந்து I told you work function is nothing but integral f into dx னு சொல்லிருக்கு. Now what I do, இங்க நம்ம பார்க்கும்போது when you're placing this positive charge, when you're shifting from a point to b point, remember a point and the b point when I'm shifting it, now இது positive charge, it will try to repel, correct? So repel ஆகும்போது opposite it will try to move. So it will try to move in opposite direction. So repulsive force act item. Remember, they'll be having some repulsive force. Okay, when you're placing this positive charge on this B point. Okay, so again, or force relation irukku. Inge vandu capital Q, small q, the distance is R. When you're integrating it, the final relation na kudukren, W is equal to, final relation is W is equal to your, it is K, remember it is K, capital Q, small q by R. So when you're integrating it, W is equal to K, capital Q, small q by R. Now, if you want to find the potential, so now in the work function, I'm potential substitute. When I substitute the relation in your potential, so V is equal to W is nothing but it is K, capital Q, small q by R by small q. So small q will get cancelled. It is K Q by R is your electric potential at point B. Okay, remember this relation. So in the work function important, V is equal to W by Q. In the work function important, in the potential important. Okay, boxes panada relations ella note. Okay.
Yes, sir.
Right now. Okay, I'm just erasing it. As usual, I'll save it. So now I erase pandren. Right. So now when you're discussing about the potential, now formulas enna நம்ம discuss பண்ணது நான் இங்க எழுதுறேன். So first one we have seen potential difference VB minus VA is equal to W by Q. இதோட unit வந்து joule per coulomb or volt ன்னு சொல்லிருக்கேன். Okay, and second one it is potential VV is equal to W by Q, same unit. And here work done is equal to, I told it as Q into capital Q small q by R. Remember in the formulas are important. And after that we have seen the potential with respect to your force relations. It is a K capital Q by R. So in the relations are important. Now, so with these relations, there is a graph or a small graph here. And the inner graph number. So in the graph we are going to compare with respect to electric field. Electric field your electric potential or a graph. Okay, so you'll see the relations. So now the x-axis in the x-axis I'll take it as your distance. X-axis I'll consider with respect to your distance as R. Okay, and y-axis I'll take with respect to potential V and your electric field. So idu thaniya adu thaniya draw. So when you're drawing it, first we'll see the relation. So potential is inversely proportional to R. Remember, V is inversely proportional to R and E is inversely proportional, inverse square. Okay, it is 1 by R square, it is 1 by R. Rendu graphs parabolic la da irukku. Okay, rendu graphs parabolic la irukku. So first E. So the graph will be like this, parabolic. Okay, and V, because the distance it will be, it is 1 by R, so slowly it will try to gradually decrease. So the graph will be like this. So electric field E is equal to, it is 1 by R square. So it is proportional to 1 by R square and it is your V is proportional to 1 by R. So both are parallel to each other and both are parabolic relations. Okay, remember these relations. Okay, so this is a small graph when you are comparing it. Not particular. So now, as usual, now recording irukku. So in the screenshots I'll share these screenshots. Few screenshots I have recorded. Okay, so I'll erase this one. We'll see the dipole. Again, inge oru dipole irukku. So on the dipole, we are discussing with respect to your electric potential. Remember, நம்ம electric field directions discuss பண்ணிருக்கோம், but இங்க நம்ம directions discuss பண்ண மாட்டோம். We'll see the difference between the 2 points. Okay, we'll see one by one. First case for the axial. Dipole ரெண்டு applications, one is axial, one is equatorial. First one the axial part. So I'm taking a dipole. So which is minus q and it is plus q. So both are separated by a small distance of 2l as usual. So from the center it is L, from the center it is L. So it is your dipole moment P vector is equal to Q into 2l. Okay, this is a dipole moment. Now on the same axis, I'll taking a point P. On the same axis, I'll take a point P. Other distance part. So the distance is from the center to the point P as x. from the center to the point P as x. Same cases. நீங்க முன்னாடி என்ன டிஸ்கஸ் பண்ணிருக்கோம் அதே cases. It is x minus L and from the center, from the A point, it is x plus. So now the A point and the B point. Now we are going to find the potential difference at B point, at P point. So here potential difference also always we are going to add these two. இங்க வந்து நெகட்டிவ் இருந்தாலும் பாசிட்டிவ் இருந்தாலும் what are the terms அது நான் வந்து அப்படியே எடுத்துக்கிறேன். இங்க டைரக்ஷன்ஸ் நான் கன்சிடர் பண்றது இல்ல. So V is equal to VA plus VB. V is equal to VA plus VB. First VA பார்க்கலாம். VA is equal to from A point to the P point. A point and the P point to the difference. So VA is equal to, it is K. So the charge is minus Q. Only the sources based on the discuss பண்றேன். Minus Q by the distance is X plus L. இங்க வந்து equation வந்து V is equal to, it is K Q by R. இங்க வந்து R square வராது. Remember that. So இது first. Then VB is equal to positive nala, it is KQ by X plus L. Now we are going to add these two. So B is equal to, it is K, that is minus Q by, it is X plus L plus K Q by X minus L. So from these two relations, நான் என்ன பண்றேன்னா KQ common எடுத்துறேன். KQ common எடுத்துட்டு when you do the cross multiplication, நான் final equation மட்டும் எழுதுறேன். So it is nothing but K, Q into 2L by, it is X square minus L square. So A square minus B square. Okay. So it is equal to Q into 2L is nothing but dipole moment. So it is K P by X square minus L square. This is your relation for electric potential axial. So you can take it is as B axial is equal to. Okay. Kp by X square minus L square. This is your relation. Okay. Now, this is a special case. If X square, you know, I think the square terms, if X square is much greater than L, if X square is much greater than L, so V axial is equal to, so இங்க வந்து X square much greater than L ன்னு சொல்லும்போது L square we can be neglected, so the relation will be Kp by X square. The relation will be Kp by X square. This is your relation. So it is for axial point. Okay, so not பண்ணுறோம். Or right now, so I'm just deleting this one. Okay. So next one we'll see the equatorial. For this equatorial point, nalla paathuka equatorial romba important inge. So as usual, I'll take a dipole. So inge dipole la vandu there'll be having some charges present in it. So in the charges eppadi irukuna, it is your negative charge minus Q and it is positive charge. It is nothing but your dipole. So from the center, it is O point and either length L and total distance is nothing but your 2L. Now, so for this, I'll take a perpendicular point. So I'm taking a perpendicular point. So equatorial is nothing but your perpendicular. Now, so for this perpendicular, I'll take the P point here. Okay, so the A point and the B point and I'll take this distance as X from the center to the point P. Now, either distances for these distances from the A point to P point, there'll be having some field. அதே மாதிரி for P point to B point, there'll be having some field. இங்க வந்து நான் distances based பண்ணி தான் discuss பண்றேன். Difference தான். There is no directions here. So again angle theta, again angle theta. So இது வந்து hypotenuse as usual. It is nothing but your X square plus L square. அதே மாதிரி இங்க வந்து hypotenuse, it is X square plus L square. This is your relation. Now, when I'm discussing about these things, so first of all, we'll see VA. So VA is equal to, it is minus K Q by square root of X square plus L square. So it is your VA. And VB is equal to plus KQ by square root of X square plus L square. This is your relation at the P point. At the P point, potential now V is equal to VA plus VB. V is equal to VA plus VB. Now we'll see the difference. So இங்க வந்து நான் ரெண்டு add பண்றேன். So V is equal to VA plus VB. Add பண்ணும்போது it is minus KQ by square root of X square plus A square, L square plus KQ by square root of X square plus L square. So ரெண்டு வந்து சேமா இருக்கிறதுனால the potential for the perpendicular is equal to 0. So for this case, equatorial வந்து for the perpendicular point, so distance சேமா இருக்கும்போது the potential will be 0. So here remember, here இங்க வந்து potential for this perpendicular to 0 nala, there is a third condition is here. The third condition enna, so we are taking any general point from the dipole center. Okay, so now on the any general point from the dipole center we are taking it. Okay, instead of taking the perpendicular, any general point, other picture and it will be like this. So பார்க்கும்போது, so it was making an angle from the center and taking point. Okay, இந்த மாதிரி வந்து I'll take the angle. Now we'll see. So here it was making angle theta. So இங்க வந்து perpendicular இருக்கு. Remember இங்க perpendicular இருக்கு, it was making angle. So இது minus q and it is plus q. இதோட distance பார்க்கும்போது, I'll take this as a point, I'll take this as b point. இது center, இது L and இது L. The total is nothing but your 2L. Okay, so now from the center. Now a point and the p point. So p point is on the surface. So like this. So this is your p point. So a point and the p point, it is a lengthy one, and I'll take this one as r1. And b point p point I'll take it as r2. இது நீங்க already வந்து bookல படிச்சிருப்பீங்க. Same concepts are நம்ம discuss பண்றோம். So they'll be having some resultant between these two. So all are having direction, so all are your vector quantities. Okay, now this is your p point. Now when we're discussing about that, again இங்க வந்து என்ன பண்றோம்னா ஒரு perpendicular point from the center நான் வந்து நோட் பண்றேன். ஒரு perpendicular point இங்க இருந்து. So when I draw a perpendicular point, so it was meeting here. Your perpendicular point. In the difference எது இருக்கோ, இது வந்து r1 minus r2 ன்னு சொல்லிட்டேன். In the difference வந்து I'll take it as r1. Again, the final relation. So just in the picture மட்டும் memorize பண்ணிக்கோங்க. So for this general point making angle theta, so the potential B is equal to the final relation. I'll write it as B vector because இங்க வந்து directions எல்லாம் இருக்கு. So B is equal to it is kp by r square. B is equal to kp by r square. So here, because it was making angle theta with respect to dipole, so I'll take it as cos theta. Remember this relation, it is kp by r square cos theta. Okay, so in the cos theta relation, the angles வந்து உங்களுக்கு vary ஆகும். If theta is equal to 90 degrees, b is equal to 0. If theta is equal to 0 degrees, b will be maximum, it is kp by r square. In the kp by r square தான் we have discussed earlier, that is your axial point. Okay, same formula தான். Okay, remember this formula enough. Okay, now idhula when you are discussing with respect to your vector quantity, so b vector is equal to, okay, b vector is equal to, it is k p vector r cap by r square. K p vector r cap by r square. So this is your relation. Okay, idhula special cases on the thetas. If theta is equal to 0 degrees, so if theta is equal to 0 degrees, other than already solid, that is your axial point. So if theta is equal to 0 degrees, that is your axial point. So B axial is equal to kp by r square. If theta is equal to 90 degrees, that will be B is equal to 0. If theta is equal to 180 degrees, it will be negative. That is your minimum. B minimum is equal to minus kp by r square. So these are your relations. So இது வரைக்கும் நீங்க நோட் பண்ணிக்கோங்க. So balance we'll see in next class. Okay, so உங்களுக்கு வந்து இந்த screens நான் share பண்றேன், and as well as I'll give some screenshots to you for your problems. கொஞ்சம் practice பண்ணுங்க நீங்க. இன்னைக்கு நான் ஸ்டார்ட் பண்ணேன். Okay, electrostat already சொல்லிட்டு volume 1 from your class 12 எல்லா டாபிக்ஸ் எல்லாம் இன்டர்லிங்க் தான், ரொம்ப இம்பார்ட்டன்ட் தான். நான் வந்து கான்செப்ட்ஸ் எல்லாமே என்னென்ன இருக்கு எல்லா கான்செப்ட்ஸ் தான் எக்ஸ்பிளைன் பண்றேன். So problems வந்து I'll share you tomorrow. For the first half, we'll discuss about the second chapter. That is your as per NCERT second chapter and the capacitance relations எல்லாம் இருக்கு. Then after that 1 hour we'll do some problems. Okay, so any doubts? Have taken these things?
No, sir.
Right, ma. So we'll discuss tomorrow. Right? So I'm just erasing it. Okay. So ma'am, வந்துட்டீங்களா? Ma'am?
Yes sir, I'm here.
Okay, okay ma'am. நான் உங்களை host பண்ணிடுறேன். Okay ma, tomorrow we'll see. So கொஞ்சம் practice பண்ணுங்க. Okay, I'll share you all the details with you. And நான் recording வந்து நான் stop பண்ண மாட்டேன். ஏன்னா at least 1 or 2 members-க்காவது அது யூஸ் ஆயிடுச்சுன்னா it was better. இல்ல யாருக்கு யூஸ் ஆகலன்னா எனக்கு டைம் வேஸ்ட் ஆகுது, எனக்கு டேட்டா வேஸ்ட், இங்க நெட்வொர்க் கனெக்ட் ஆக மாட்டேங்குது. Okay, if you are taking it, if it is useful, then I'll do it. Okay, right. So tomorrow I'll see. Okay, bye. Bye ma'am. நான் host பண்ணிட்டேன் உங்களுக்கு. Okay.
Good morning, ma'am.